All right, so we are going to continue on with our trace evidence section here and looking at fibers and textiles. Now, this is going to be probably not quite as in-depth as what we saw with the section on hair, but there's still a fair amount of evidence a fair amount of information that we're still going to cover with this particular section. So we'll just go ahead and jump right in and kind of continue on with where we left off. But fibers and textiles, what we're looking at right now are going to be either natural or man-made materials that are going to be used in the production of clothing or carpeting or bedding or curtains, or you get the idea, right? There's any number of things that various materials are going to be used to manufacture. But just like we saw with hair, forensic scientists are going to try to use the information that they're able to find to create that link. Right now, with our fibers and textiles, unless you have something that is exceptionally unique in terms of its manufacture or something like that, it's probably going to fall into the category of class evidence. Um, Simply because there's a lot of, let's say you've got I don't know, a red jacket. There's lots of red jackets. But if you have a very unique or one of a kind handmade red jacket, that's a different story altogether. But in general, it's going to fall into the category most of the time of class evidence. And so you say, well, how can that then be of any forensic value? And the answer to that is if you have lots of pieces of um, class evidence that all tie back to your suspect and potential crime scene, that's a lot of coincidences to exist for it just to be dumb luck. And so investigators and forensic scientists would be able to use that to, again, calculate the probability of certain types of fibers showing up or whatever the case might be. So again, it's going to be used to as a part to kind of build that bigger piece or bigger part of the case against a particular individual. So again, ends up being obviously very, very important. So just like we talked about with hair, there are a number of transfers that are going to take place um, with fiber evidence in particular. Um, when you think about the materials that we come in contact with all the time, whether it's from clothing or whether it's from furniture or whether it's from who knows what, there's any number of materials that we're going to come in contact with. And so that becomes very, very important. Now, again, we've talked about direct versus secondary transfer in our hair stuff. So direct transfer would be basically in the setting of a victim or suspect, victim to the suspect, or suspect to the victim. Right, that's going to be a direct transfer, and then your secondary transfer would be maybe from some other source onward. Right, so maybe the individual picked up, I don't know, some an item of clothing, got that material on them, and then transferred it somewhere else. That's a secondary transfer. So it didn't necessarily occur at the commission of the event or at the crime, but was simply transferred later on or previously unrelated to the case, right? So that can take place as well. Um, but we have lots of exchange that's taking place all the time. Now, when you look at a lot of your television shows and things like that, they tend to show this as being a very lengthy process, and it can be. That is very accurate. But what's going to be very important is that these fibers are collected in a very short period of time, because as you can see here, just going through our daily lives, the scientists estimate fiber loss at 95% within the first 24 hours. So what that simply means is if you were to wait longer than that 1 day period of time, the likelihood of finding any or very many fibers is going to be very, very limited. And I shouldn't say fibers, but um, fibers that are of importance, those things that are outside what would be considered normal for that particular individual. Okay, so only the unusual fibers are going to be the ones that should be looked at. Um, in one of the texts that we look at, that I think that's related to this particular topic, they talk about um, like white cotton. White cotton's not a great fiber to be basing a case upon. There's lots and lots of items that you and I come in contact with that are going to contain white cotton fibers, or most likely, lots of opportunities for us to come in contact with white cotton fibers. However, again, if you find something that is unusual to that particular individual, all right, so I'm here, I'm going back to hair again, but you could do the same thing. So um, maybe the individual hates nylon, and you find a nylon fiber attached to one of their socks, right? That would be an unusual thing. Um, and so you could use that obviously as part of the case to show that linkage, right? Textiles are going to be clothing, carpets, upholstery, whatever. Again, kind of what I started with and mentioned at the beginning, that have been woven or intertwined um, in some capacity to form some type of product. Specifically talking about yarns, that we'll talk about that towards the latter part of this section as well. So being able to find the fibers is going to be really the first task that's going to be undertaken. Um, Again, I go back to the white cotton fiber, the fact that it wouldn't necessarily be a great piece of evidence because it is so prominent in lots of different items that people might encounter, whether you're talking about shirts or undergarments or socks or um, maybe stuffing in a coat or any number of things, right? The insulation in a coat. There's lots of different ways that we could come in contact with that. So probably not the best choice in terms of trying to identify something unique and very, very specific. So there are going to be other things that obviously scientists would look for. So when or as fibers are found, the or as um, from a fiber standpoint in trace evidence, these are the types of things that scientists are going to try to answer, right? So what type of fiber is it? What color is that particular fiber? And again, that can just show an association with a particular location. So maybe you have a body that was dumped somewhere. On that body was a red fiber. The individual didn't have anything on that was red at the time. They have a potential suspect, and the suspect has red carpeting inside of their vehicle. Okay, does it match, right? So then you're going to start the process of being able to see, does that fiber match from the victim match the material that is present in that vehicle. All right. So again, the others, how many did you find? Again, that can indicate struggle. That can indicate a longer period of time that they had been in contact with those fibers. Again, maybe being drug across the floor or something along those lines. All of that can be useful. Where was it recovered from? Is it from an unusual location? Again, finding weird um, fibers on your socks probably isn't that uncommon if you don't wear shoes in around your house, right? You're just walking around as other people come in and out with shoes on and whatever. Obviously, there's going to be the deposition of other fibers over time. What type of textile it basically originated from, how many different fiber transfers were there, type of crime committed. All of these things are going to be very, very important in terms of categorizing the importance of that evidence. So in terms of collecting evidence, again, it's going to go back to the photography piece and the documentation piece, making sure that you've got everything identified, but different ways that it can be done, kind of similar to what we saw with the hair collection. Special vacuums, they're going to have special filters to be able to collect that evidence and analyze it individually from individual items of clothing. Again, you would never vacuum multiple pieces of clothing to analyze. It would be one at a time. Sticky tape. Again, this is a different type, so just the side that's down is sticky to be able to allow them to lift that material. And then the forceps for plucking or picking individual fibers as well. To be able to identify those, oftentimes an alternate light source is going to be used to be shown across that object, bright lights, and then magnifying glasses. Very careful, very thorough examination. And now I do like this picture. You'll notice the brown looks like butcher paper almost, if you will, um, is laid down for them to do the examination on. So as they move this article of clothing, if anything is dislodged and comes loose from this top, it would then be deposited on that paper. So you have a sterile environment, or not a sterile, but a clean environment to reduce the likelihood of cross contamination. Gloves, uh, everything is sealed off because again, you and I in our daily lives, and the investigators in their daily lives are going to come in contact with lots of different materials. So you want to reduce the likelihood of any of those being deposited, reduce the likelihood of that cross contamination. So again, be able to identify where those fibers came from. So if you think there is something there of value, you want to be able to document where that was. So I would anticipate that the individual that is doing this, as they have them on that article of clothing, would take some photographs to be able to show, yes, this is where I had applied that sticky tape. Once I removed that sticky tape, I saw what appeared to be different fibers, analyzed those. You get the idea, right? That would be very, very important. Depending upon how many fibers are recovered, it's going to dictate the type of testing that can be done. If you don't have very many fibers, you don't want to risk compromising their integrity or destroying them. So there are some tests that can be done without destruction of the fibers. Other tests are going to require that the fiber ends up being destroyed, but that'll be dictated by the number of fibers that end up being discovered. Polarizing light microscopy and then the infrared spectroscopy are both going to be considered non-destructive because both of those are just going to be shining beams of light on the fibers that are recovered, and then allowing the scientists to make some interpretation in terms of what they see. Thin layer chromatography, the burn test, high pressure to liquid chromatography, and uh, gas chromatography, mass spectrometry, those are all going to be destructive means of analyzing the chemical makeup, primarily the chemical makeup of those particular fibers. Burn test isn't used for the chemical makeup so much as it is to analyze some of, or at least one of, its physical characteristics in terms of whether it burns or whether it melts, bends towards the heat, bends away from the heat, so on and so forth. All very, very important pieces when you're trying to determine what type of fiber or textile you might be dealing with. So here are your specific examples. Polarizing light microscopy. Again, you can see how um, when this filter is used, you're able to see certain wavelengths of light that are being reflected, others are being absorbed, and so that allows scientists then to be able to determine possibly the makeup of that particular fiber. Again, being able to identify shapes or the arrangement of those fibers, even maybe how they're woven together. If it's not able to be determined in any other way, the polarizing light microscopy can help with that. The infrared spectroscopy, again, looking at the absorption and reflection amounts, right? So it's going to rely on light again, just like we saw with the polarizing light microscopy. Um, and so again, you can use this to get an idea of what the chemical makeup might be. Again, this isn't a definitive type of test. This would be more of a presumptive type of test, but still very, very useful. So just like we saw with the infra, the polarizing light microscopy, this also does not damage that sample. Okay. All right. So in terms of fiber classification, there are a number of fibers that are going to be naturally occurring. And naturally occurring fibers simply means it came from an animal, it came from a plant, or it came out of the ground. And out of the ground meaning it was mined specifically for its particular characteristics. But when you look at the different natural fibers, as I mentioned, animals is going to be probably one of the big ones because it's used so frequently. The hair, fur, or webbing, in this case, talking primarily about silk, are going to be the main components. They're going to be harvested. And again, it can be used in lots of different things, whether it's carpet, whether it's certain types of clothes. Think about some of the parkas or winter coat type things that have a fur. If it's natural fur, that are going to line maybe the hood or the sleeves or something like that. Curtains, bedding, if we're talking like silk sheets or something like that, all of those are going to be naturally occurring because they came from animals. Now, many times with your animal fibers, they end up being spun to make them more comfortable, maybe to make them softer, to make them more durable, or to make them fluffier, or whatever. You get the idea. Different characteristics, whatever characteristic that we're trying to impart on that material as humans. Um, that's basically what that would entail. Okay, so that's the animals. In terms of plants, the characteristic, the common theme that you'll find for all plant-based fibers, they're all going to be made up of cellulose. Okay, so cellulose is that carbohydrate. It's a relatively large carbohydrate that's going to be used in the manufacture or the makeup of plants, and it allows them to be strong and resilient and all those types of things, which again imparts great qualities or characteristics to fibers or textiles that are made as well. So something to be mindful of there. The fibers themselves are often relatively small, 2 to 5 centimeters, and over time they tend to become relatively brittle. They're not an exceptionally durable material for long, long, long periods of times. So you can have stuff from the leaves or from the stems or from the seeds or even from the fruits themselves. So in the textbook, it mentions the covering from coconuts. Other things that they mention in there, they're going to talk about like cotton. Right, cotton is in the seed pod of the cotton plant. Right, so again, there's lots of different ones, obviously, that are going to be used, and each of them has a very specific purpose, depending upon what characteristics or qualities that particular material has. And then the last one is going to be that of the minerals, right? They're not made up of proteins. They're not made up of cellulose. These are going to be minerals that are going to be found in the ground. And again, they can take lots of different forms depending upon what that material is. Fiberglass is a good example, asbestos, as well as others. Just is going to depend upon what that material is and then what it ends up being used for. So fiberglass obviously frequently is going to be used as an insulation. Asbestos has historically been used as a heat material, a heat resistant material, I guess I should say. But obviously, once scientists found out that there is a strong uh, component that may or allows asbestos to contribute to lung disease and lung cancer, people have kind of gone away from that, which isn't necessarily a bad thing. All right, so those were the man-mades. The synthetic, I'm sorry, the previous were the natural occurring ones. This slide, we're looking at the synthetic or man-made fibers. And with these, this is kind of a big group. Um, but these are all made in a similar type of fashion. You're going to have the material itself that's going to be melted down in large vats. Um, and again, it can include some naturally occurring materials as well, but typically they're taking these smaller subunits, the monomers, and then joining them together in and forming these big polymers. And again, what they're going to do is they're going to then drain that vat that has all of these melded monomers in there, and as they drain that, the spinnerets are going to produce a very specific and characteristic shape associated with them. And the shapes are going to be used to impart specific characteristics to those fibers themselves, whether it makes them stretchy or makes them weave together really, really, really tightly. Maybe if you're talking to be able to form something that's going to be highly water resistant, or makes them extremely durable, or whatever, right? You get the idea. There's lots of different characteristics oftentimes that will be used in terms of identifying these things. Okay, so that's how they end up being manufactured. Again, sometimes you'll have the natural fibers that are going to be incorporated as part of that, just to impart maybe a better um, insulative value associated with it, whether you're talking wool or cellulose primarily. A lot of the synthetic ones are synthetic fibers are going to have shapes that are going to be specific to certain manufacturers. And so again, there is or are databases that scientists can go back and look at. If you have a certain type of carpet, maybe that has um, a certain weave pattern or a certain um, fiber shape, as that particular material was drained out of those vats, whether it's rayon or nylon or whatever. Again, can use that to help identify it. So when you're comparing them, again, you'll notice that this is one of the first things, because it's non-destructive, is going to be microscopic examination, right? And so once you have that, then you're going to then figure out, well, what do we have to do next to figure out um, what material we're looking at. And so you can see here that it's going to break it down from natural and synthetic, obviously using fluorescence and other processes to determine the characteristics. So both natural and man-made or synthetic fibers have their good and bad characteristics. One of the downsides associated with natural fibers is that they are very subject to microorganism infestation. Microorganisms love naturally occurring products because, again, they're going to be found on living organisms and they're readily available. And so microorganisms can then begin to break those materials down and render them um, basically useless, right? Whether you have something that's gotten in and um, consumed some of the textile or whatever, put holes in items or whatever the case might be. So that's a big problem with naturally occurring stuff. With your synthetics, the exposure to ultraviolet light in particular is problematic. A lot of your synthetics don't handle UV exposure for prolonged periods of time very well, and then certain temperatures are going to cause them to degrade a little more quickly as well. So again, you can kind of see pros and cons associated with each. The weave patterns end up being very important. We'll talk about that here in just a little bit as well, as we finish up this little section. But with each of these, you can see certain characteristics that are going to be used in helping to identify the makeup, the textile makeup for particular items. And so scientists can use this to help identify what material is there, the different weave patterns that will exist, and this is not um, an exhaustive list by any stretch of the imagination, but this just gives you an idea of kind of what some of the different weave patterns are, um, and why they exist. So again, each of the different weave patterns have certain characteristics associated with them. Like, this is why the manufacturer would want to use those. All right, so that becomes very, very important. Yarns, I had mentioned at the beginning, are made by spinning together fibers, smaller fibers typically, fibers that aren't very long, spin those together, and then spin all of those longer segments together as well. And so you create or can create much thicker, more durable, stronger material than what the individual components are initially. All right, so I have on here rope is a really big yarn, which really, if you think about it, it is. You're taking individual strands, you're spinning those together, and making a thicker, more durable material as a result of spinning everything together. So obviously, the practical application is pretty apparent. With these, you'll often find a blend of materials to produce a specific outcome that you might be looking for. One of the things that scientists will look for is the direction of twist. Again, certain yarns that have directions of twist that can provide clues as to where that material may have come from or what manufacturer may have produced it. Okay. So as we talk about textiles, specifically, whether you're talking curtains or carpeting or clothing or whatever the case might be, basically looking at the different materials that go into making objects that we use. So some of the earliest textiles that were made are going to be baskets. by taking different materials and weaving those materials together, whether it was twigs, whether it was reeds, whatever the case might be. Those were woven together to form a particular product, right? And so, by definition, that meets our criteria. So that would have been a natural material that was used to manufacture those products. And then it progressed, right? So you've got linen then during the Stone Age, and so on. I mean, so on and so forth. You could go on from that, whether you're looking at the weaving looms or any of that stuff, kind of when they have shown up, or the use of silk or whatever, right? All of that is going to be very, very important. So basically, weaving is the arrangement of threads or material lengthwise, side by side, and then close together. So you put those fibers in very close proximity to one another, both lengthwise and side by side, and uh, the degree of closeness in each direction will impart certain characteristics and qualities to that object, whether you're making it exceptionally strong, whether you're making it very water resistant, whether you're making it um, stretchy, whatever the case might be, right? The way that those materials are woven together helps to dictate some of the characteristics. Again, patterns that are going to be used in the manufacture of textiles can be useful in identification, whether you're looking at the shape of the weave itself. If we go back to that previous slide where we showed all the different, like plain or basket weave or so on and so forth, and then also thread count, right? How many pieces of thread are in a particular um, material in a certain area. Again, the greater the number of thread count, oftentimes we think of it in terms of bedding. The greater the number of thread count, the softer, more luxurious that particular item would basically be. Okay. All right. So again, there's lots more that really we could get into, but I think that definitely gives you more than enough in terms of overview, in terms of what's taking place. And so that is where we will stop with our fabrics and textiles.